to another edition of Math Sounds with Sindoni. Today's episode is brought to you by this very dirty ramshot ball. Must have been well loved and or left out in the grass for about a year. Here we go. Ramshot. Better than spike ball. Whoop, 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 whoop. Ah. Oh well. Alright, we're going to talk about section 1.5, last section of chapter 1. This is going to be infinite limits. Okay, an infinite limit is a limit in which f of x increases or decreases without bound. Okay, to say that a limit approaches infinity or negative infinity is pretty much to say that the limit doesn't exist. So if the limit x approaches c of f of x is equal to infinity or negative infinity, that is to say the limit, we'll just write d, does not exist. Alright. And what you see here is our official definition of a vertical asymptote. Where, as you saw before, we now have definitions for continuous and vertical asymptotes now that we know the limits of calculus here, the definition of limits. Alright, so let's look at vertical asymptotes. Alright, let f and g be continuous on an open interval containing c, and h of x equals f of x over g of x if f of c does not equal 0 and g of c equals 0, but g of x does not equal 0 for all the other values that aren't c. Okay, so for every other value it's not equal to 0, then x equals c is a vertical asymptote. Okay. Alright, let's do some properties. Properties of limits regarding infinity. Properties of infinite limits. There we go. Okay, so let's define if we have a limit as x approaches c of f of x. Let's say that goes to infinity. However, the limit of g of x goes to some number, we'll say L. Then what do we get out of this? Let's see. Limit as x approaches c. Let's say we add these together. Okay. Sorry, it should be an x. Alright, so if f of x goes to infinity and you're adding or subtracting some number to it, it does not matter. It still goes to infinity. Alright. Let's say you have some multiplication. F of x times g of x. Oops, bracket. we get? Well, we get two options. We get negative infinity if L is greater than 0, of course. And we get negative infinity if L is less than 0, of course. Alright, so infinity times L is positive infinity, negative infinity, or I'm sorry, infinity times negative L is negative infinity. Alright, I ran out of room. Let's just go over here. Let's go in the middle here. And then the last one for division, the limit as x approaches c of g of x over f of x. That one's going to equal 0, okay, because if you have some number divided by infinity, okay, it's gonna just go to 0. Okay, you have a number here, but you have a massively large number that continues to increase. It's just gonna, that fraction will just go to 0. The other way is something we don't like. Okay, that goes to infinity because if you have infinity divided by L, that just continues to increase without bound. Alright, let's look at the book pages. Oh, there's that pen. Alright. We have our, let me get some of this out of here. We have some infinite limits here. In case you want to read some of this. Next page, rational functions. There are those properties. Here are the homework problems, which I will be assigning on Google Classroom. Also, keep in mind, we have office hours at 11:30 every day this week. So if you need some help, stop on by, get a glimpse into my home. And that's not, oops, review. I don't think oh yeah, I did do some on here. There we go. Alright. Thanks for watching.